Greetings, everybody, wherever you are in South Africa and beyond. This is Learning Masters Tutoring. Okay, in this lesson, I'd like to go through this year, and by this year, I mean November 2025, grade 12, Maths Paper 1, final exam. And I only want in this video to just go through question 1, which was an algebra section, which was out of 25 marks. It was mostly equations and inequalities. All right, so let's get started. Okay, so let's get into it. Just going to set up my pen. Okay, let me write in black. Okay, let's start with 1.1.1. It says solve for x. Let me minimize my face here so you can see fuller screen. Okay, so now I just need to quickly erase this here. Shouldn't be there. I was writing earlier on. Okay, so now 1.1.1, it's x plus 5 times x minus 2 equals 0. So the golden rule with math, if you have two or more brackets multiplied to equal to 0, then you set each of those brackets equal to 0, and then you get separate equations, then you solve them. Math way of saying this would be if you have two or more factors multiplied and give you 0, then set each of those factors it's equal to 0, and then you get equations and you solve. So brackets, factor, same word. I tried to teach you the formal math language because understanding the language helps you to understand math better. Okay, so with the first one, since it's two brackets multiplied equal to 0, to solve this, literally you set each bracket equal to 0 and then you solve. So x plus 5 equal to 0, or maybe this pen is too thick, let's make it thinner, or x minus 2 equals 0. I think the thinner one is faster. So all you do now, this is a grade 8 equation, can solve this by inspection or take these numbers to the other side. You get two solutions, x is equal to minus 5 or x is equal to 2. Here, then you are done. So that would be your 2 marks. So your 2 marks would come from here, 1, 2. Done. Let's go to the next question. The next question, let's go 1.1.2. Now it says here 5x squared plus 2x equals minus 9x. Correct to two decimal places. Most of the time when they give you the bracket correct to two decimal places, it implies that you will need to, or you find it useful to use the quadratic formula. And how will you get to that? Well, this looks like something that's quadratic. And remember, quadratic form is ax squared plus bx plus c equals 0. That's a quadratic form. All right, that's a quadratic equation. That's a form of a quadratic equation. So first we have to put this into a standard form of a quadratic equation by taking the negative 9x to the other side. So then it becomes 5x squared. It's a bit too tiny. Make it a bit thicker. Okay, it's going to be 5x squared plus 2 plus 9x is equal to 0. Okay, you can now rearrange this, put in standard form. It's 5x squared plus 9x plus 2 is equal to 0. Now, you could try and find factors of 5 and 2 and try and do it in the normal factoring way. You won't find those solutions. So what then you will need to then employ the quadratic formula, which is a formula x is equal to minus b plus minus the square root b squared minus 4ac over 2a. Okay? The a value is 5, the b value is positive 9, the c value is positive 2. It's according to this form. Okay, so now you just substitute minus 9 plus minus the square root of b squared. B squared is just going to be 9 squared minus 4. The a value here is 5. The c value here is 2. Okay, all over 2a. 2 multiplied by a. A is just 5. Then you simplify this on your calculator, you're going to get two solutions. You're going to get one solution that is x is equal to minus 0.26, and the other one is x is equal to minus 1.54. So those are the two solutions you get. X is equal to minus 0.26 and x equals to minus 1.54. Okay, so here that looks a bit funny. Let's just write it neatly. Okay, so 5 and 2, we get these two answers. X equals minus 0.26, x equals minus 1.54. Remember, I typed this on my calculator, and with the one solution, I put a plus here. With the other solution, I put a minus. That's what plus minus means. Plus minus means you have two solutions, one with the plus, the other with the minus. And then I just rounded off to two decimal places, as they said, get minus 0.26 and minus 1.54. How do you check? You substitute this into this and you check if it's the same left and right. You'll find something such as minus 0.002 on both sides for both solutions. And that confirms that those are the valid answers. All right. Okay. I hope that helped with 1.1.1 and 1.1.2. Let's quickly jump to 1.1.3. Let's quickly go to 1.1.3. I'll change the thickness of this pen. I think this third level of thickness is better. So I change it because the thin one looked like it was writing faster. Then I noticed that I'm compromising neatness. That was not the intention. And then I saw now that this third one here looks like it's better. This third one, this third thickness. Okay, so now 1.1.3. It's slow, but it's not that slow. It's actually decent. So you have the inequality 8x squared is greater than 2x. With this one, you also approach it as a quadratic. You want to put the trinomial on one side of the operator. This symbol here is called an operator. So I can take the 2x to the other side. I get 8x squared minus 2x is greater than 0. Now, how do you solve an inequality? You must always find the critical values. The critical values are the values where this, in this case, it's a binomial, are the values where that function would do with these two terms, this function, 8x squared minus 2x, you want to find the values where it equal to 0. That's what you want to do. That's not going to give you the solutions. It's just going to give you the critical points, which basically lead to your answer. So we solve this equation. We're going to pull out, to solve this equation, you pull out highest common factor of 2x, because that's the highest common factor. I'm going to get 4x here. I'm going to get minus 1 there. Once again, two things multiplying equal to 0, set each of those to 0, and then you get equations. 2x equals 0, or 4x minus 1 equals 0. Then I'm going to get two answers here. X is equal to 0. This pen looks a lot better, by the way. And then I get x is equal to 1 over 4. Those are the critical values. This is a happy phase parabola. So that means I have a happy phase parabola. These are the points. Remember, this is where I set the function equal to 0. Those are like my roots. We call them roots in maths. Those are the points where the function crosses the x-axis. And those are the 2 points. This one here and that one there. The one is going to be when x is 0. The other one is going to be when x is 1 over 4. And this graph is a graph of 8x squared minus 2x. What is this inequality saying? This inequality is saying we're looking for where 8x squared minus 2x is above 0, greater than 0. The 0 line is always the x-axis. The 0 line of any function is the x-axis. This is the 0 line of any function. So when they're saying this is a line x equals 0. I mean, this is the line y equals 0. It should be y equals 0. And this then is saying, this inequality is saying, where is this function above that line, above y equals 0? Because this here, this 0 here represents y equals 0. So they're saying, we want to know the x values where the function is above the y equals 0 line, above the x-axis. Well, here's the part that people struggle with, and I hope to not to get you to be on board. So if I look at this parabola, when it's stretching towards the left this way. Um, past if I go to the left of the point x equals 0, the parabola is stretching that way. If I go to the right of the point x equals 1 over 4, the parabola is stretching that way. And these are the parts that are above the y equals 0 line. This part here is under the line y equals 0. That would be less than 0. So that's excluded. So we want to know, what do the values of x look like for the parts of the function above the 0 line? And for this one, we know it's all the values to the left of x equals 0. With this one, we know it's all the values to the right of x equals 1 over 4. So we write it like this. Values to the left of x equals 0. So those are values of x smaller than 0. That's to the left. Or x values to the right of x equals 1 over 4. You can say x is greater than 1 over 4. I use a union symbol. X is less than 0. Union x is greater than 1 over 4. You can also simply write this like this. That's one interval for x values less than 0. That means values to the left of x equals 0. And you can also write x greater than 1 over 4, which means values to the right of x equals 1 over 4. So that covers this question. So now we've covered these three. I hope it answers you and helps you to understand, if you're in grade 12, what you should have done. If you're looking at this and you're currently in grade 11, or you're currently still studying your grade 12, I hope it gives you enlightenment. Okay, now I want to move on to question 1.1.4. I want to move on to question 1.1.4. 1.1.4. Okay. Okay. Now, question 1.1.4 looks like this. 1.1.4. Okay, it's 2 multiplied by 2 to the power of 2x minus 9 times 2 to the 2x. Oh, 9 times, it's actually, it's 9 times 2 to the x plus 4. That's plus 4 equals 0. Okay, this kind of question should remind you of a quadratic. Look at what a quadratic looks like. Something squared, a term squared with an x squared, a term with an x to the power of 1, and a constant. This is actually representative of a quadratic. And you can use this, you can approach this question doing something called the K method, which is like a substitution. So if I let 2 to the power of x, because 2 to the power of x is acting like this x over there. If I let that be called k, then I can rewrite this, because If I took if I wanted to find k squared, what does k squared mean? Well, it means you would take whatever k is, which is 2 to the power of x, and then raise it to the power of 2. And then the second law, or one of the laws of exponents, says when you raise a power by another exponent, you multiply them. So you know that after writing this, you can see that if k is 2 to the power of x, then 2 to the power of 2x is actually k squared. So then I just rewrite the substitution. 2 k squared. So I replace the 2 to the power of 2x by k squared minus 9. 2 to the power of x is k. Okay. And so that we've got. Now you need to find factors that satisfy this equation. Well, the factors, there's many different methods, so I'm not going to go through that part. Use your method to work out the factors. You should get 2k, unless if you have the calculator that can do this for you, which is also fine. 2k minus 1 minus 4. Then like once again, two brackets multiplied to give you 0, set each of the brackets equal to 0. For the first bracket, I'm going to get 2k minus 1 equals 0. Second bracket, I'm going to get or k minus 4 equals 0. And then I get two solutions. Solve this equation for k. You're going to see that I'm going to get one solution here. K is a half. The other solution here, this is an or k is equal to 4. Now I should just back substitute. Substitute back what k originally was. K is 2 to the x. So now for this first one, 2 to the x is equal to a half. Then a half is 2 to the minus 1. So you get one solution of x is equal to negative 1. Or the other solution, 2 to the x is equal to 4. Well, 4 is 2 squared, so this one will give you x equals 2. So you end up with two answers here. X equals 2 and x equals minus 1. Those are the two answers you get for this, and both of them, I've checked them, both of them satisfy this equation. All right? Okay. I hope this was helpful. We are approaching the end. We're left with just these two. Hang in there. All right, I just want to erase this 1.1.4. Okay, we're only left with two questions, so hang in there. After these two questions, we will be done. Okay, let's go ahead and do 1.1.5. Now, this is a very interesting question, but we can actually do it with an approach similar to the previous question. That's a way you can do it using the, okay, so this is the equation. All right, you've got this big surd, the square root symbol is called the surd. It kind of makes things inconvenient. So the very first thing you want to do here is square both sides. That's the very first thing you want to do. Why would I want to square both sides? If I square both sides, I get rid of the big square root. Okay, square both sides, I'm going to be left with square root of. Now, here's another thing. Okay, I can just do it step by step. Square root of 1 over x plus 2. Why is it just that on the left? Well, the square root has disappeared when I square. Inverse operation of square root is square. Then here, square root the tops, square the bottom, square the top. Square 1, you get 1. When you square something with the square root disappears. So square root of x squared just becomes x. Now I want you to pay attention carefully. I'm going to put everything on one side. I want you to notice that one thing I wanted to get to was that here, remember there's a way writing square root is the same as saying 1 over x to the power of a half. Okay, let me fix that x here at the bottom. Square root of 1 over x can be written is this equivalent to saying 1 over x to the power of a half plus 2 equals 0. Then let's say I've taken let okay, let's just do step by step. I was about to skip a step, but I think now this is 1 over x. Look at this. This is 1 over x to the power of a half. This is 1 over x to the power of 1. It again resembles a quadratic because something squared, something to the power of half of that, and a constant. Well, half of 1 is a half. So if this is a 1, 1 over x to the power of 1, it's playing the same role as the x squared. And the 1 over x to the power of half is playing the same role as the bx. So I can actually rewrite this in a quadratic form as 1 over x. That's the same as 1 over x to the power of 1. That's this term. And then these two guys I take to the other side. 1 over x to the half minus 2. Once again, something to the power of 1, and then power of a half, that's half of that power. It resembles a quadratic form once again. Now I can make my substitution to make it very clear to you that it is in the same form. So if I let my k method again, I'm going to let k equals 1, let's see, let k equals 1 over x to the power of a half. So then I need to figure out what is k squared then. Well, k squared then would be taking that 1 over x to the half and squaring it. When you raise a power by another exponent, you multiply the exponents. 2 times a half, that's 1. Well, that just becomes 1 over x. Because 2 times a half is 1, and then that becomes a power of 1. So then I get this quadratic. 0 is equal to, remember 1 over x to the power of 1, that's k squared, minus 1 over x to the power of a half, that's k, so minus k, minus 2. So this is a quadratic you actually end up dealing with. And the factors you end up with, once you simplify this or factorize that, you get k plus 1, k minus 2. And two brackets equal to 0, set each bracket equal to 0. So k plus 1 is 0. Or k minus 2 is 0. Remember what k is, right? I'm just going to finish it here because it's quite long. Remember k is square root of 1 over x, which is the same as saying 1 over square root x. So I'm going to take this first equation. 1 over square root x plus 1 equals 0. I'm going to solve that. Take the 1 over. It's going to be 1 over square root x is equal to minus 1 times by square root of times by square root x on both sides, and then square both sides. What you end up with, you're gonna end up with x equals 1. Now if when I substitute x equals 1 into both sides of this equation, I don't get the same answer. Okay, because here I skipped some steps. Remember, it should be a step you have in between here is that you're going to times by square root x on both sides, going to get this. And then you just square both sides. Square both sides. It's going to be 1 is equal to, the square goes away, and the square root goes away. It's going to be x equals 1. But when you check this solution, it actually doesn't equal on either side. So I said not applicable. But what about the other equation? So you get, this is just this equation. I got a second equation, k minus 2 equals 0. So for that one, I'm going to say 1 over square root 2, I mean 1 over square root x, because that's what k is equal to 2 times both sides by square root x times both sides by square root x. Then I'm going to get a half is equal to square root x, because I divide both times by square root x on both sides divided by 2. Then I square this, I get a final answer of x equals 1 over 4. And that is a valid solution. X equals 1 over 4, that is a valid solution for this equation. That actually satisfies the equation. So that would be the answer for 1.15. Okay, all right. I'm going to quickly do the last one, 1.2, and then we end the video. Just going to wrap up 1.2. It's a simultaneous equation. Give it in words. It just needs you to read with understanding, and then you will see that it's actually quite easy. And I'm going to do just one method via substitution. Then I'm going to end the video. Okay. All right. So 1.2. Calculate the values of x and y. If, that means x and y at the same time, that's simultaneous equations. If, so each of those bullet points gives us an equation. It says if x is a sum of 2 and y. So it says if x is a sum of 2 and y, sum means add. X is, in English we say x is, in math, x is means x equals 2, and the sum means plus. The sum of what? 2 and y. So x is equal to 2 plus y. That's your first equation. Great, this one wasn't so bad. What about the second equation? You get a second equation to deal with here. It says that 5 times the product of x and y. So 5 times the product of x and y. The product of x and y is just xy. 5 times, that is 5 times x and y. So 5 times xy is going to be the same as saying 5xy. Is, the word is means equal to, is 6 more than the square of x. 6 more, which means plus 6, than the square of x, which means x squared plus 6. So 5xy is equal to x squared plus 6. That's equation 2. Since I already have x as a subject of a formula in the top equation, I'm just going to say take equation 2 and substitute it into equation 1. 2 into 1. I'm going to get 5. Where there's an x, I'm going to replace. It should be, so since it's 5xy, I can just say 5y multiplied by x, which is 2 plus y, is equal to, where there's an x, 2 plus y squared plus 6. Okay, distribute the 5y. 5y times 2 is 10y. 5y times y is 5y squared. When you're squaring a binomial, you use a shortcut. Square the first term. 2 squared is 4. Square the last term. Y squared is y squared. And then to find the middle term, you times these together times by 2. 2 times y is 2y times by 2 is going to be 4y. And then plus 6. Then you're going to have to simplify that, collect like terms. You're going to end up with 4y squared. I'm just trying to shorten the video now. Plus 6y minus 10 equals 0. That's where you end up. And you divide that whole thing by 2. Divide that whole equation by 2. It's going to be 2y squared plus 3y minus 5 equals 0. Then you're going to get 2 factors, 2y plus 5 multiplied by y minus 1 equals 0. So I get then two values of y, x equals 1 or, I mean, y equals 1, or y equals minus 5 over 2. Once you have that y value, come and back substitute it here, each y value independently, you'll get a corresponding x value. So for x equals 1, I mean for y equals 1, you get x equals 3. For y equals 5 and a minus 5 and a half, this is minus 5 and a half. For y equals minus 5 and a half, for y equals minus 5 and a half, minus 5 over 2, you're going to get an x value of negative a half. All right. That would be your final answers. Sorry that this was quite a lengthy video. I just love to go into detail because I believe having a strong and solid foundation is useful. All right, I hope this video helped you if you're in grade 12 and enlightened you about what you ought to do. If you're in grade 11, I hope it also enlightens you. Okay, remember you can reach us for tutoring at Learning Masters. Use the number WhatsApp and call 071 400 9965 071 400 9965. Thank you so much. Have a great day or evening, whatever time it is. Good luck with your exam, and I hope you work with us. Let's take the journey with you to improve your mathematics and strive for maths excellence. Bye.